what is a function? Function is special relation between two objects. So if you have here x, and then you have function of x, then you may have value 1, 1, 2, 2, 3, 6, and so on, so on, so on, okay? What else you can use to define a function? A formula, a graph, a list of pairs. So, all possibilities, correct? Now, in our course, we have a specifics. N is an integer, and f will present integer as well. So that is a limitation of our course. So now what we can do, let's take this and put it in the form of the sequence. So I have 1, then I have 2, then I have 6, then I have 24, correct?
Yes.
And so on, so on, so on, so on, so on. Now, I can say that is a function of a position, and position of n was 1, 2, 3, 4, and so on, so on, so on. So we have a sequence. Agree?
Yes.
Now, if I have all those numbers written down, then there is a solution for a function or function in explicit form, which will be the way how it was introduced in the table. But if we have infinite number of members, we don't know what's going to be here. I cannot tell you what is it here. That's why I cannot say I have that table. And then I have a chance to guess that my relationship between each two numbers look like that A of n equal previous value times a position, n times A of n minus 1. That is a recurrence relation. Here's a very sensitive point. We cannot prove it using mathematical induction because we don't know the average formula for the k. But what we can say is we will use that relation to define our function. So all numbers here will satisfy it. If something here or somewhere else will not satisfy, it's a different function. I don't know that function, I don't want to talk about it, okay? So, recurrence relation. That was introduced in chapter 5, agree? Now, what to do with that recurrence relation? Let's say we have specifics. Is first of all, we know what that n is. We have domain. So it started with the 1, then we say that A of 1 equal 1, okay? And we have initial condition. So domain integers, initial condition, A of 1 equal 1. Now we can use a relation and those two additional informations to compute any number, correct? So this plus this will be a recursively defined function, because the result of it will be a number, okay? that will give you chance to find the value of that function for any given n. How you start with the 1 and you move on to the next, to the next, to the next, correct? Make sense? So that called a function. Relation is here. Let's forget about relation. Now you can use some manual, sequences, steps, calculator to do it, or you want to have computer to do it. Then you will use the same relation, but now you will make a method. So what you will have some computer language. You will have that algorithm to compute the number presented in the form of the method, okay? Now that method, in the way how we define it, has a nature of recursive type, okay? That's why our method will be most likely a recursive method. And then you will have name of that method. Then in a body somewhere you will call the same name. And then is a recursive method. And then, in order to have a recursive nature, you need to call that name with the different parameters. So that it's totally different from this one. They will produce the same result, but you have now a method. And originally you had a function, okay? Does it make sense? Because again, I'm trying to be very precise with words. I don't want to say any extra word, and I don't want to have those words to be kind of not clear. And final, kind of related to that, but not exactly the same. Now, if you will take that method and try to find out how many steps it will take to execute it, then you will have time complexity function. And if you cannot directly compute time complexity function from the expression or from the body of that method, that you may create equation for the time complexity function. Then that equation, it's not the same as your original recurrence relation. And it's not the same as the relation that you use in your method. So you have relation for the numbers, you have relation between function calls, and you have relation between number of steps for execution of each of those function calls. It's all relation, and in some books it's all mixed up with the same names, but we need to understand. That is a sequence, which is a function. That is a relation between elements of that sequence. That is function defined based on that relation to compute the numbers. That is the method, recursive by nature, to compute the same. And outside of that problem, you have time complexity function to count number of steps. So those are many different words, and they related to the different parts of our problem, to the different or view on the problem or steps of the problem, okay? Does it make sense? Okay, that will be it. I will post it.